students, welcome to our online video class of chemistry. Today we are going to study about voids and packing efficiency. Voids. Voids literally means gaps between the constituent particles. Voids in solid state means the vacant space between the constituent particles in a closed packed structure. You have already learned about close packing. Close packing in solids can be generally done in three ways. What are they? One-dimensional close packing, two-dimensional close packing, and three-dimensional close packing. In two-dimensional structure, when atoms are arranged in square close packing and hexagonal square packing, we see some empty space left over between the atoms. This is the square packing. You can see some empty space between the atoms. And this is hexagonal packing. Here also you can see gaps between the atom. And this gap is called voids. So what is voids? Voids are the vacant space between the constituent particles in a close packed structure. If a void is formed by arranging three particles, we get a triangular void. And the tetrahedral void is formed when one sphere or particle is placed in the depression formed by three particles. Now it becomes tetrahedral void. The vacant space or void among the four constituent particles having a tetrahedral arrangement in the crystal lattice makes tetrahedral void. Here the particles are situated like this. We get a tetrahedral void because in between the four particles there is a void, and the coordination number here is 4 because there are 4 atom or particle are in between the void. Thus the coordination number is 4. Now you see how a tetrahedral and octahedral void is formed. Then what is tetrahedral void? Tetrahedral void is formed when one sphere or particle is placed in the depression formed by three particles. The vacant space or void among the four constituent particles having tetrahedral arrangement in the crystal lattice make tetrahedral void. Coordination number of tetrahedral void is 4 because the vacant space is surrounded by 4 spheres. This picture shows the formation of tetrahedral void. An octahedral void is formed when three close packed spheres forming an equilateral triangle. Suppose this is the equilateral triangle formed by three close packed spheres. If we place this over another set of three spheres in opposite direction. This is the another set of three spheres in opposite direction. If we place this triangle over this, we get octahedral void. That means the vacant space or void among 6 constituent particles have octahedral arrangement in the crystal lattice. Makes octahedral void. An octahedral void is formed when 3 close packed spheres forming an equilateral triangle are placed over another set of 3 spheres in opposite direction. And the vacant space or void at the center of 6 spheres or atom forms the octahedral void. The coordination number of octahedral void is 6 because the vacant space is surrounded by 6 spheres. The number of these two voids depend upon the number of close packed sphere. Let the number of close packed sphere be n. Then the number of octahedral voids generated equal n, capital letter N, and the number of tetrahedral void generator equal to 2n. Placing third layer over second layer. Now let us place third layer over the second layer. Stacking of third layer over second layer can be done in 2 ways. First is by covering tetrahedral void. Second is by covering octahedral voids. By covering tetrahedral voids. This type of arrangement, the third layer is placed on the tetrahedral void. In this type of arrangement, the third layer sphere is exactly same as the first layer sphere. So, we can call it as ABAB type. Suppose the first layer is A and the second layer is B and the third layer become A because the third layer is aligned exactly same as those of the first layer. And the pattern of the layer is repeated and the structure is called HCP or hexagonal close packing. In this type, each sphere is in contact with the 12 other spheres. 6 from same layer. 6 from same layer A and 3 from bottom layer and 3 from top layer. Hence, the coordination number of it is 12. Example for this is beryllium, magnesium, cadmium, cobalt, etc. Covering octahedral voids. In this kind of close packing, the spheres of the third layer is not aligned with those of either first layer or second layer. Thus we name covering by octahedral voids. In this type of close packing, the spheres of third layer is not aligned with those of either first layer or second layer. Thus, if we name the first layer as A and second layer as B, then the third layer will be C. Then the arrangement become ABC type. In this type, the coordination number is 12. This structure is called cubic close packing or face-centered cubic structure. Examples for this video includes voids and different types of voids and how the voids are formed. I have uploaded one more video on the topic packing efficiency. Download it and study.